Hello again, Algebra 1. What I have today is a video to help prepare you for what you'll be doing on Monday and Tuesday, October 5th and 6th. We've been working with equations so far, and we've been playing with how you can do 1- and 2-step equations, and we also have been looking at what happens when you need to combine like terms or deal with decimals as part of the process. This is really all review to help make sure that you are ready for this year, and it continues to tie into lesson 1.2 as we go and do it. There's another type of problem that I'm going to have you work with, and I wanted to demonstrate a couple of examples so that you would know what to expect. On this example here, I see suddenly that I have something a little different. I've got these parentheses, and it's telling me that I have 4 multiplied by some number plus 9. You've seen parentheses used before for grouping sometimes, and here they mean something that's very important. What we're going to be doing when you see the parentheses here is we're going to take that number 4 and we're going to multiply it by each of the terms that are on the inside of the parentheses. Like that. I'm going to slide this down just slightly there. Here's why that's important. So I've got this number 5 at the beginning of the equation. It tells me I have 5 plus 4 times n plus 9. And that n plus 9 is a group that's being multiplied by 4. That means that I can take the 4 and multiply it by n and make it look like this. When I do 4 times the number, I just write 4n. There's no sign that has to go in between them, and it just stays like this. Now let's see what else I have to do. I have 4 multiplied by 9 also. So I add that on because I have a plus sign in the middle. Both numbers are positive. And 4 times 9 is 36. So you can see why the multiplication that I was having you do the last couple of weeks is very important. So we have the equation now written in another form. I wanted to give you this video to show that there are times when I need to combine other terms that are happening. Here we only have one place where we have a variable, 4 times n. But instead, we have these numbers getting added alongside it. 5 and 36 are being added together in that problem. And what I really want to do is combine them together so that they are only one number. 36 plus 5 is 41. And so I leave plus 41, and I write 4 times n here because I did not change it. And now I'm ready to solve the problem. What I see is that I have the number 41. I remember that I always have to add or subtract first. Since I see adding, I do the opposite, and I subtract. I'm going to draw a line to show I need to do it on both sides, like this. 41 minus 41 is canceled out. But negative 3 gets combined with negative 41. I can think of those as being added because they're both negative. When I add those together, I end up with the number negative 44 because 41 plus 3 is 44, and they're both negative numbers. So I use a negative number here. That leaves me with 4 times n on the left side still. The nice thing is now I can just quickly go through and I can show what will happen to the rest of it. 4 gets divided on both sides. So I cross off the 4's on the left side because 4 divided by 4 is 1. N is the only term left over. And make the line to show I'm ready to finish. Negative 44 divided by 4 is going to be a negative number because I have a negative on top and a positive below. 44 divided by 4 is 11. So negative 44 divided by 4 must be negative 11. So there we have the process for when you have to do an extra step at the beginning. I want to give you the name for what that is just up here. Distributing is what happens at the very beginning. And then you follow it up with what we were looking at on Wednesday and Thursday. When you see the parentheses and there's a number outside, you have to distribute at the very beginning. Then you look for any terms that you can combine, and you combine those like terms. Then you see if you can add or subtract one of the terms, and then you see if you can multiply or divide the last term. So we have this very definite process: distribute, combine like terms, add or subtract, multiply or divide. I'm going to go through a little more quickly with the process on two more examples so you can watch. I recommend taking some notes with this as you go. I chose these examples because they give me a chance to show you what happens when we have more than one negative number in some cases. I notice I have -4 this time. I want to distribute first, so I'm going to mark that back over here as step one. Distributing means I take the whole entire thing. I have this -4 that's right here. I'm going to underline the whole thing. I treat that as a number, -4. And I go and I multiply -4 times the missing number, d. And I multiply -4 times -3. And I'm going to make a little bracket there just to show I keep the sign, that negative or minus, that's in front of the 3 with that number so that I do it correctly. Here's what I will have when I distribute. The 7 stays on the outside at the beginning. -4 times d gives me -4d. -4 times -3, those are both negatives, so I can see the eyes of the dozing man, so I put a plus sign because he's asleep and he's happy. 4 times 3 is 12. And it still equals 23 like the original equation shows. I notice right now that I'm ready to go and combine like terms because I have more than one like term, so I'm listing this as step 2. I have 7 and I have 12. So I'm going to highlight those here. 7 plus 12 is going to give me a positive 19, so I put plus 19, and I've still got this -4d at the beginning at this point. There's not very much that I have to do. Subtract 19 next, because I know that my next step is either to add or subtract. And I can see that I have a positive 19, so I need to subtract 19. So what I have now is I have -4d on the left, the plus 19 and the minus 19 are gone. And on the right side, 23 minus 19 is 4. Here's the last piece. -4d equals 4. I'm ready to divide both sides because this is being multiplied. So I'm able to divide both sides by -4. And at the very end, by dividing that, I have d only on the left. And 4 divided by -4, well, the 4's are the same. So I'd have a 1, except that one of them is negative. So I put a negative outside. My final answer is d, the missing number, is equal to -1 because of the 4 divided by -4. Sometimes I have to go a little further with this also than I normally do. Let's see what happens on the very last one that I have right here, and then there will be a few others that I'm going to have us try. Quickly, I'm going to distribute. On this problem, I have 2 times something called 3 times t minus 8 on the inside. -4t equals 10 on this problem. Let's see if I can distribute again. 2 times 3t is 6 times t, or 6t, because of the 2 times 3. 2 times -8 keeps the negative there with the number. 2 times 8 is 16, so I'll be subtracting 16, like this. Now I write in the rest of it. I'm trying to keep it lined up as best I can, but there you are. The -4t and the equals 10 stay put, like this. And I've done my distributing. Now I'm ready for the next piece. Six times t minus 4 times t. 6 minus 4 is 2. And the t's stay put like this. Notice how it's okay for me to have the 2 times t at the very beginning. I know that earlier I was showing the numbers getting put at the end like that. It is actually up to you to decide what order you put these in when you're ready. I like having the t on the left side if I can, because that's the variable. So I've got 2t minus 16 equals 10, and I'm ready to finish the process. I have a minus 16, so I need to add 16 to follow our third step again. Minus 16 plus 16 will disappear, and that leaves me with 2 times t on the left and 10 plus 16 on the right, which is 26. I can finish the last part by just going and dividing, and now I'll get my answer. 2 divided by 2 makes 1. I only have to write the variable t. 26 divided by 2 is 13. And I see that I accidentally had that go out of frame, so let me go ahead and fix that for you there. There we are. Just to recap that last step, since you missed it, I think, just a moment ago there. So 2 times t equals 26. Dividing both sides by 2 gives us 13. So that's the process of working with a complete set of these problems. Let's scroll it out so you have a chance to see the whole entire thing. There it is. Okay, I have some problems that I left out of this because I didn't want to use those. On each and every one of these, I can distribute first by multiplying a number that's on the outside of the parentheses. Just like that. Each time, I have terms that need to be combined because I see either the variable showing up in more than one place, or I have numbers showing up in more than one place that don't have a variable. Once I combine them, then I'm ready to go and do the normal steps that I've been doing all along. I can go back and I can add or subtract, whichever needs to happen here. And then each of these cases showed how to divide. We haven't really seen much happening with multiplication when that's needed. So I wanted to finish the lesson that I have here with a couple more examples, just to let you know what happens if you see a fraction occur in a problem. There's going to be exactly one like that on your assignment this next Monday or Tuesday. Sometimes we have fractions working their way into what we do, and I wanted to let you know how you could work with those. So here's what I see. I have something like 2/3 times x. That means I have 2 parts out of every 3 of something, and it's equal to 10. I want to know how much I really am multiplying that. So here's what I do. I start by multiplying by 3, like this. I'll put multiply by 3, and I'll do the same thing on both sides. So I put the dot to show I'm going to multiply, and I can cross off the 3's on the left side because it really is 3 multiplied by some fractions out of 3. That gives me 2 times x right here, and that's what that's saying. I'm left with 10 times 3 in the problem, and that's 30. Now I can go and I can divide. This is a case where I have to do both multiplication and division to solve it correctly. So when I do that, dividing both sides by 2, I'm left with the number 15. And that's saying that if I have 2/3 of the number 15, then it's equal to 10. And that sounds right to me. We can play with that process a little more and to see what it does. I'm going to actually try speeding it up slightly. Maybe instead of having to show the steps separately, maybe I could try doing them a little more quickly. Let me try this. Let me try multiplying by the denominator on this next item here, 9 like that. And let me see if I can go and I can divide also. Well, I see that I had to divide using the number that was on top last time. I had the 2 times x. This time I have 4 times w. Let's see what happens if we divide by 4. And here's something interesting. I see that I've taken the original fraction I had in problem 6 here, 4/9, and I have flipped it upside down. I have this 9 here and that 9 there, and they would cancel out. I have this 4, and it's getting actually divided by that 4, so those cancel out. All that is left over is the variable, w. I can go and I can do a little more math with it. -8 times 9 would be, I'm going to write that up here so I can put the final answer down below. That's -72 if I do -8 times 9. And I see that I'm supposed to divide it by 4 also. I can check how many times 4 goes into -72. I know I'm going to have a negative because of the negative on top. 72 divided by 4 would give me the number 18. So that's what I have. I have a -18 in this particular problem, and I can do that by just taking the fraction and flipping it upside down. There is a special name for that process when I can use a fraction that's been turned upside down, and it is called a reciprocal. So a reciprocal is a special name for a fraction that I can use that is simply another fraction flipped upside down so that I can multiply the two. So this is a way, in just short, to describe a reciprocal, a fraction flipped to multiply. And here's what else I have. I have a couple more examples that I can try. Let's try and see what happens if I take this fraction and flip it around. I'd be multiplying by 5 and dividing by -6. And I do the same thing on both sides, and I get to multiply here, which is nice. So on the left side, I have 5 divided by 5, and I have -6 divided by -6. The only thing left over is the variable. Let's see what happens when we work with this. 12 multiplied by 5 is 60, and that's not too tough. 60 can be divided by -6. 60 divided by -6 will leave me with a -10. You can see how that works very nicely for us. We can just lay it right in and just work with it. This last one here is the most similar to the problem that you will have to solve on part of the homework. I have -1/2 times m equals -9. Let me see. I can take this and do the reciprocal also. And I can put the negative wherever I'd like for it to be. Let's have it be -2 this time. And I'm going to divide it by 1. So let's put it like this. I have -2. I made my multiplication dot a little low there, so I'm going to fix that. So I got -2 multiplied by -9 rather. And I also will divide it by 1. Let's go and clean this up a little bit. So the -2 and -2 cancel out, and the 1 and 1 cancel out. If I have -9 times -2, the negatives are gone. I'm left only with the number 18. I have a 1 on the bottom, and I do not need to list that. Dividing by 1 is the same as just having the number on top. So I have 18, and I can list that as my answer. So that's how these fractions work. I'm going to try to hold that still for you there. This is the cool thing about these fractions. I can go and I can multiply both sides and then divide, like I did back in problem 5 up here at the very top. But that's the same thing as multiplying by the original fraction turned upside down. so that the denominator becomes the numerator and the numerator becomes the denominator. In other words, the bottom becomes the top and the top becomes the bottom, so that I can cancel out the original fractions on every single equation. It's a really cool process. Hope you enjoyed seeing this, and I look forward to seeing you on Monday and Tuesday of next week.